and this one is 3.23 part D. Here we have a cantilever beam which has these 2-point loads. So looking at this support here, there will be a force acting upwards. So if you call this R, you can see this R will balance these two forces. Effectively the value of this R is going to be 0, and there will be a bending moment here. Let's call that mz. So if you do the moment balance here, your mz minus PL minus A, because of this force right here, distance here is L minus A, plus PL because of this force about this point is going to be PL equals to 0. You can see the value of mz in this case, this PL and this PL will cancel out, so you are going to get minus PA. So this value right here is minus PA. So on this problem we have a point moment and then we have 2-point loads. So point moment we have in this form, x minus A minus 2, and for point force we have x minus A minus 1. And for integration we already know that this becomes minus 1 power after first integration and 0 after second integration. This will become 0 after first integration and 1 after second integration. So let's define the intensity function for this beam. So your intensity Qx, we'll start with this one first. So minus PA at 0 point moment, that's by minus 2. The next one is your this force here. So P, it is at x minus L minus A. Since it's a point force, we get minus 1 here. And the last one is acting downwards, this force right here. So minus P, brackets we have x minus L minus 1. Now when we start evaluating for this beam, this function will never be positive. X minus L will never be positive for this beam, so we can ignore this. So now for your shear force, we can integrate this once with a negative sign from here to here. So minus Q dx. So we have Vx. We will flip the sign, so PA x minus 0 minus 2 integration gives us minus 1. Flip the sign again, x minus L minus A minus 1 will give us 0. So this is your shear force. Similarly your bending moment, we can integrate this one more time, so minus P dx. Flip the sign, so minus PA x minus 0 minus 1 becomes 0, plus P x minus L minus A, and this becomes 1 after integration. So now this beam, how many segments we have? We have this first segment which is x less than equals to L minus A, and the second one is x greater than L minus A. So let's look at those two segments. So your segment 1, which is x less than L minus A, and your segment 2, which is x greater than L minus A. Now in segment 1, your x minus 0 function is going to give you a positive argument, and in this case both x minus 0 and x minus L minus A will give you positive. So from here we calculate your V1. So for a V1 we'll consider only this part right here. Now this function right here again is a unit impulse function. So basically this value will be infinite at x equals to 0, and everywhere else your V1 is going to be 0. So in brackets we can write at 0 V1 is undefined, or V1 is equals to infinity. Everywhere else it is 0. For MB1 we'll evaluate this function. It's going to give us minus PA times 1, because x minus 0 to the power 0 will give you only 1. Similarly we can go to segment 2. So now for segment 2 V2 we have to evaluate both of these. First part we have already calculated, so we can write V1 plus the second function. In this case it's going to be minus P. Inside we are going to get x minus L minus A to the power 0, which will give us 1. So we can just remove this. So your V2 value from here, everywhere it's 0 V1, so V2 becomes 0 minus P, which is minus P. Similarly your MB2 here will have MB1 because of your first term. To that we are going to add this second term, which is nothing but P and polynomial x minus L minus A, so it becomes plus A. If I substitute the value of MB1 there, so MB1 is minus PA plus PX minus PL plus PA. These two cancel each other, So finally we get a value of MB2, which is, if I be common, x minus L. So we have got all the values. Your V1 is 0, your V2 is minus P, MB1 is minus PA, and MB2 is Px minus L. It's very easy to plot, only constant and linear functions are there. But remember, at 0 it's going to be undefined. So let me just give you the final graph. So after plotting, this is how the shear force and bending moment diagram looks. And the important thing here is that the value of shear force is undefined at x equals to 0.